So let's say you have two vectors A and B right over here. And from vector A, uh, you start at the tip, and then you want to add another vector to vector A so that this vector is perpendicular to vector B or orthogonal. So this means that you have a 90-degree angle here. And basically what you want to know is that you want to know what the projection of vector A onto vector B, what this is. Okay, and this is just another vector. I'll call it vector X. And vector X is actually just the component along B, right? Added to this, like the negative of this purple vector, and then you get vector A. So then I'll actually just use color to represent vector X. So this is vector X right over here. So vector X plus this purple vector, the negative of it, because we have to switch the head to the tail, and then that should give me vector A, or in other words, vector A plus the purple vector. I'll call this n over here. A plus n gives me X, right? So tip to tail. So starting from here, I go to A, and then I add n, I end here. So in the end, I start from here and then end over here. And vector X is actually it's a scalar multiple on vector B. Okay, so we just need to figure out what vector X is. Okay, so what do we have to do here? So how do we find vector X? Vector X, this is equal to A plus n, vector A plus vector n. Okay. Now, A plus n gives you X. X is a scalar multiple of B, because I could take vector B, this entire red vector, and then I can multiply by a scalar, and then it can shrink it, or in this case, it's going to be shorter. Just for this particular example, it doesn't have to be shorter, because if I do vector B along vector A, the projection of B along A is going to look something like that, whereas this is going to be negative. So, but it's just a scalar multiple. So this is just equal to some scalar multiple C times vector B, where C is a real number. Okay. So vector A plus vector n gives you CB. Okay, so what if we take this equation over here? So I have A plus n. This is equal to CB. And what if I just dot product both sides, right? I dot product both sides with vector B. So B dot A plus n, and then B dot CB. The dot product is distributed. It is also commutative. Okay, so this is just the same thing as B dot A plus B dot n, and this is equal to C times B dot B. Okay, but what is B dot n? Notice that B and n, they are orthogonal, perpendicular to each other. Okay, so this is 90 degrees, this is 90 degrees, and therefore the dot product between two vectors that are perpendicular to each other is equal to 0. Okay. So what we just have is that we have B dot A is equal to C times B dot B. If you divide B dot B on both sides, because B dot B, this is a scalar. This is a real number now. Okay, this is dot product is also known as the scalar product, right? So B dot B, two vectors dot product each other, that gives you a scalar. So when you divide B dot B on both sides, what do you get? We get that C is equal to B dot product with A over B dot B. Okay, so this is actually the scalar we want. This is the scalar we want, so that when this scalar, this real number is multiplied with vector b, that gives me x. Okay, so we know c is equal to a dot a over b dot b, and this will imply that x is just equal to b. I'll actually write it as a dot b over b dot b, and then times the vector itself. Okay, and another thing is b product with itself is just equal to the magnitude of b squared. Okay, so now we figured out what vector x is. Okay, so the projection of vector A onto vector B, this vector right over here, right, can be computed using this formula. And that is it.